everybody, and welcome back to our Big Analytics Query show with me, Tom, and Simpson Associates here on our YouTube channel. Today I'm joined by Rob Constable, who is a data science expert. Rob, why don't you tell us a little bit about yourself?
Thank you, Tom. Yeah, so I've been at Simpsons for about 3 years, building out the data science capability in the business, mainly working in the sort of policing sector, doing a variety of use cases with them to sort of help them be more optimised and deliver a better service to the communities that they serve. And yeah, just enjoying doing a lot of interesting data science use cases, really.
Very nice. So today we'll be exploring all things data science, but I guess data science is such a big topic that explores a range of various different things. Could you tell us, maybe in a couple of sentences, what data science actually is?
Yeah, sure. So I guess data science is kind of a collection of tools, including things from sort of statistics, mathematics, computer science. So machine learning would be a big sort of tool within data science that gets a lot of sort of attention and interest, and that's obviously geared towards primarily making predictions from data and understanding, trends and patterns within it as well. And yeah, using all those sort of tools to build useful things from data, extracting value from data using that sort of suite of tools.
And what sort of things can you build from that?
Yeah, so you can do things like forecasting models where you sort of take a time series of quantity and time. So think about sort of a sales per location for a sort of retailer, and you might want to look at those trends and seasonalities of sales over time. So you can use a sort of forecasting model to do that. And we sort of refer to that as kind of demand forecasting. We do a fair amount of that for the police. In their case, sort of interested with sort of forecasting crime and trends and patterns of crimes and different types of crime in a particular force.
I guess just thinking about the police sector that you said you've worked mainly in, what are the benefits? Why should police forces use data science?
Yeah, I think sort of various reasons, but I think, it sort of helps them with their sort of strategic planning and policy research. So you can get a lot of insights out of data using data science tools, looking at things that might be a driver of crime or aspects of their functionality as an organisation which might be suboptimal or areas where they could improve. So you can look at how well they respond to the demand they have to address. So develop sort of measures of performance and measure those over time, but also look at sort of things, attributes within their organisational data that are kind of correlated with those sort of performance measures. So you can start to pin down why certain things are either seen in the community or are seen in terms of how the force responds to things that go on in that community that they're serving.
So it's kind of predicting things and reacting to them at the same sort of time and just gaining as much information as possible to make those informed decisions?
Absolutely, yeah. I think it's definitely double-edged data science. You've got the ability to make predictions, but you've also got a lot of insights that come out of models that generate those predictions. Because obviously models are built from data, and part of the model building process is understanding what variables are using as predictors are correlated with the thing you're trying to predict. So if that's a particular sort of, let's say for a police force, a profile of case outcomes across different types of crime, that sort of outcome distribution will be correlated with the number of aspects of those cases and crimes that they've responded to, the geography, the sort of demographics of that geography, socioeconomic factors, and we can sort of tease apart all those sort of relationships and drivers that are seen within the data, and also model those relationships to generate predictions.
So it's using both what has happened to work out what will happen, but also seeing trends.
Absolutely, yeah.
And then what about, so not in the police force, other businesses surely can use data science as well. What sort of things would you recommend people to get involved with as a first step of data science?
Yeah, for sure. I mean, obviously data science has been sort of popularised in the private sector primarily, and I think there's a lot of sort of mature use cases for data science within the sort of retail sector or the commercial world. So obviously profiling patterns of customer spending or buying patterns, that's sort of well characterised area of data science use cases. Doing things like market basket analysis to look at the sort of associations of products that are bought together, so that can kind of inform how things are packaged and marketed. Doing things like identifying what are the most valuable customers to you. So looking at the kind of customer journey and trying to sort of profile customers based on their customer lifetime value. So how recently have they bought things? How frequently do they tend to buy things? And sort of what's the value that they tend to sort of spend? So using that, you can kind of use clustering methods, one of those sort of data science tools to sort of identify what are the most valuable customers, and then sort of make sure that you retain those because they're the most sort of biggest spenders and the most valuable customers in your of your service or product.
Another one of the tools, of course, in data science is automation, and we see the rise of AI and want to know how to best use all of those tools. And how does AI work with data science together?
Yeah, well, obviously, sort of AI is kind of taking machine learning and, as you say, adding elements of automation to it, or using it to automate a process that a human being would normally do. So, for example, with the police, we're currently rolling out various products to do things like transcription of audio or voice recordings, sort of mass translation of documents using AI, and also sort of automatic redaction of documents using a product called Redact Expert. So all of those are kind of automating different aspects of what police officers are doing or what sort of force analysts are trying to do. We've got sort of ambitions to do more and more kind of AI-assisted intel search, because obviously we've got access to LLMs now, which can actually summarise and search data in an extremely effective way and generate, summaries or intel reports for you automatically from mass text data, and do that in a format that you define in a prompt that you give the LLM to sort of define the expected output that the LLM gives you. So, we're making use of AI to automate all kinds of things in policing. But the same kind of applies in the retail or commercial world, anywhere where you've got that kind of requirement to do anything that it requires a bit of human reasoning or a very repetitive process, which a human being would normally do with data. Increasingly, we're being able to automate that with AI models, with LLMs, large language models.
And then with these large language models and everything else, how is the quality of that? Because, of course, the human's been doing it for ages, and the question around AI and the use of technology is whether that's good enough.
Yeah. I think that's a really important question. LLMs, obviously, they're not perfect. They do get things wrong all the time. They famously hallucinate. I think we define it as hallucination when they start getting things wrong. In effect, they're always hallucinating. They're always kind of generating text in a probabilistic way, and that is not going to be 100% correct. But people are not 100% correct either. So really what we're looking for is systems which are, in that kind of LLM agent category, we're looking for systems which are as good or better than a human at a particular task. And the way you determine that is by rigorous evaluation of a system, right? So you might set up, an AI redaction tool. You might measure analysts doing that redaction task manually, the time it takes them to do it, but also the accuracy. And then you measure the same sort of performance of an AI redaction tool and its accuracy and the time that it takes to do things. And you can rapidly kind of mount an argument as to why that automated system will be better than a person at that particular role. It will not get tired. It will do things quicker, and once it's tuned to that task, it will do it more accurately as well. So it's just a case of evaluation and demonstrating robustness for those sorts of things.
And I guess once you've trained it, you don't have to retrain it. You can just keep developing it on, and if you can work it with the human side, and so you get a both and approach. Surely, is that not better?
Absolutely. Sure.
And what about the security side of things within data? You've mentioned all the police forces and local governments. Of course, they've got to be very careful with data and not going out anywhere and sensitive information. How do you do data science whilst using personal, identifiable and sensitive information?
Yeah, that's a really good point. You obviously have to make sure that you're sort of meeting standards of data protection and security. So for us, that would typically mean a privately networked cloud environment on Azure. So we have a lot of expertise in the business for setting all those sorts of things up. But then in regards to sort of names, addresses, bank details, things of that sort of personally identifiable information, as you say, we would look to sort of Databricks best practice, for example, if we're using Databricks as a platform for anonymizing or pseudo-anonymizing that information and making sure that that's the access to that is restricted or it is encrypted and not readable unless it needs to be read at some point. So.
Thank you very much. Now that we know a bit more about what data science is and does, where does it fit in today's world?
I think it's sort of driving innovation in every aspect of our sort of digital lives, really. So every time you're on your phone, taking an image with your camera phone, you're interacting with image processing algorithms, deep learning algorithms, processing that image, helping you do sort of AI image focusing and quality, upscaling, all sorts of things. If you're sort of watching TV, you're interacting with recommendation engines, offering you things to watch, so it's obviously completely permeated marketing and all that sort of digital advertising stuff. Recently with the sort of Gen AI revolution that's happening right now, really, Gen AI is kind of changing all aspects of media. It's having impacts across the board, isn't it? Because you've got the ability to basically generate content, but also do search and summarization of data. And that's going to be massively revolutionary. So, it's touching all aspects of life, I would say. Behind the scenes in academia and science and in business, sort of more traditional machine learning tools, data science methods, obviously they're now very mature, they're now very scalable. So the time is now really to sort of make use of all of those to solve problems in the world, in business, in the public sector, in science. There's never been a sort of better time for it because we've got the compute, we've got all the tools, and it's just a case of cracking on and building the solutions to everything, really.
And I guess because it's already being used so much in that anywhere, it's not a new idea for most of those things that's already there. It's just taking the next step with them.
Yeah.
Really. And what do you think those next steps might be without, predicting the future? We know it's changing so much at the moment, but...
I think, so from my perspective within policing, I think, using stats, using machine learning to inform policy and build products to make their job easier as a force is revolutionary. And we're only just starting to do that with UK forces. I think there's loads more work to do there. And I think it can be really impactful. That's one sort of prime example, but I think the same applies to many organisations. And data science hasn't really been a term like sort of 15, 20 years ago. It's sort of a recent sort of subject area. So I think we've barely scratched the surface in terms of the value that all these tools can provide, really.
Definitely seems the opportunities are sort of endless, and it's just what we can imagine to do with all of this data and to learn more about the things we use.
Absolutely, I completely agree.
What would you say are some common misconceptions about data science? What are people most afraid of that you would want to tell people, actually, you don't need to worry about that?
I think a very common misconception we come across is that you need a data warehouse or dimensionally modelled data or very, very high quality data to do even a POC with data science. Although that's true, that a big limitation of any BI or machine learning or data science project is going to be that data quality, because garbage in, garbage out. You want the most high quality input possible. You can learn something from any amount of data that an organisation gathers, and at least in a POC, you get an impression of what are the use cases that might work for your business and how well are they likely to do the job you're trying to get them to do. So I think a lot more, prospective clients that we work with could potentially, take the leap and have a crack at a data science POC, and we'll probably find that actually their data is perfectly fine to get started, and it is a journey and a process. And you sort of iteratively improve from that POC as you productionise and as you sort of evolve the solution that you build.
Okay.
So yeah.
And do you have any stories of that without mentioning any customers where that's happened?
Yeah, certainly. I mean, various forces that I've worked with, we've gone in there and we've done a sort of more limited POC with a particular, more narrow data science use case that's then sort of spilled into other activity areas or other sort of use cases that have emerged. Or people have seen what we've built and then have come back to us with like new requirements that we've kind of used what we built and evolved upon it and made more elaborate and complicated sort of portfolios of data science outputs.
So, Rob, it sounds like you've worked on various different projects and clients. Do you have any particular favourites or stories of ones that were really cool?
Yeah, so I can think of one. So worked with one particular force in the UK, taking them on a bit of a data science journey. So starting out sort of doing demand forecasting over different crime types for sort of government reporting, and then sort of building from there into a bit of a sort of a performance analysis of the force, looking at kind of response times and investigation times. And then in most recent sort of phase we've done with them, looking to kind of put everything together into a kind of outcome model or a risk model, looking to understand all the sort of inputs and outputs of the organisation and how they relate to each other. So understanding what our correlates are of a force's performance, how does that performance relate to case outcomes, and then looking at that sort of broken down by different types of demand that the force has to respond to. And that was really interesting. It's like multifaceted, a lot of sort of stats in the front end of it to kind of understand the relationships, and then machine learning at the end to build a model that they would be able to use to make predictions and query and understand those relationships we found and quantify them, which I thought was really interesting.
And were there any particular lessons learned or discoveries found that were key in the project?
Yeah, I mean, obviously, policy changes or data quality changes over time very important. So making sure to sample data from meaningful parts of that sort of time series that the force generates, and also all those sort of caveats of where you don't have a lot of data, you can't really answer many questions very quantitatively, and we have to caveat or qualify your statements and your conclusions with that limitation that you don't have a lot of data about a particular topic, and you can't really be too sort of confident in what the data might be showing if you've got a sort of small sample size.
And I guess because data science is so moving constantly, it's about trying to knowing that each data is different, so different clients and customers have different data, but then also still learning along the way and taking bits from all the different sources and kind of trying to learn as you go.
Yeah, definitely. Yeah, so with that particular force, we were looking at incident data, staffing data, socioeconomic data, and pouring all that into a series of statistical analyses and modelling to relate it all to itself. And it was really interesting, really varied.
Great. And tools and technologies, what do you use to actually do the work that you do?
Yeah. So typically I would use Azure Databricks as a sort of data science platform of choice on any project. That's because it's got a sort of the most performant Spark backend of any sort of any platform in the cloud, and a suite of features that are really good for doing machine learning and data science at scale. So you can use Spark SQL or PySpark to write your queries, to do your ETL, to bring data into the platform. You can orchestrate all that if you want to within Databricks. But then you've got all the MLOps tools and all the sort of ML library support that you need to do like a range of data science use cases. And then also train models and put them into production. So do MLOps where you register experiments and record experiments, save models and deploy them to compute resources so that they can be used for real-time inference if that's what you want to do. Or just use them in batch and use them to write tables to a star schema, in much the way that we do with other sort of warehousing projects.
And do they all work, all of these tools, together nicely?
Oh, they do. Yeah, it's a really nice environment to work in, and quite a robust and mature technology now. It's really good for doing machine learning and data science at scale, really.
Yeah, I'm aware we've mentioned lots of LLMs, large language models, and other sorts of complex technology.
Yeah.
If all of this is feeling a bit too much, not understand, and people have stopped watching, what's the one thing that you would say people to start with on this journey?
Like a first use case?
First use case, first step into understanding why data science is useful and how it can practically be used.
Yeah. I think it depends on, I guess, the nature of the business you're going into and what data they're generating and looking at. I would tend to be led by a kind of business problem and then just use whatever use case kind of applies to that.
Yeah.
But generally speaking, things like what I've spoken about, using LLMs to do free text search and summarization and search is massively important across all conceivable organizations. Demand forecasting in practice is very valuable to most organisations because it's so valuable for sort of strategic planning. And then sort of more generically, I think every organisation's got a need for some element of risk modelling. So they've got some outcome or measurable output that they want to predict, and then they've got a bunch of correlates of that or variables that they're able to measure that they could use to predict that outcome. And that's a bit sort of more abstract, but I think, in policing that's really obvious because that's like the outcome of a case or the performance in which a case is sort of addressed. For other sort of domains, retailers or local and regional government clients, for example, that could be like the outcome of a child that's been in social care and been monitored, and you want to look at the interventions that have happened and their kind of demographic attributes and understand, how well they're doing servicing that sort of profile of people. And those are the kind of relationships and types of models that you can build with data science tools.
And with these risk models, do you have any top tips or things that people should either definitely do or definitely stay away from when doing these?
Well, if it's a risk model that's talking about human data, there are considerations surrounding the performance of that model and any biases. So as soon as you introduce any human attributes as a predictor, you have to be very careful that you're not sort of algorithmically victimizing a group in society because they're sort of a minority group which is sort of underrepresented. So models are trained from data. All data sets are kind of imbalanced and have skew. And when that comes to sort of human attributes, you have to be mindful of those performance differences that you'll see in the model output. A result of those sort of differing representations of people in society and in the training data that you're going to use. So you have to be very mindful of that.
And other than as a human taking that kind of step back and really questioning the outputs of any of the models, are there stuff I can do within the model, steps I can take to make sure that I kind of catch it before it's too late?
With respect to sort of
to the risk
model on human data.
On human data, yeah.
On human data, yeah. So you can use tools to basically identify your model's performance against different subpopulations within society, and then you can sort of catch a model which is basically underperforming in a particular group and take steps to mitigate it. There's other things you can do in the way that you sort of fit the model to sort of account for what's called class imbalance more generally. So when you've got different categories in the training data, there's strategies that you can employ to account for that to an extent. But definitely something you have to be mindful of and look to mitigate and quantify.
So that's something to kind of be aware of happening.
Yeah.
Is there anything that you'd recommend definitely doing?
I mean, first of all, only bring in those features if it's absolutely necessary, and then if you are going to bring them in, definitely quantify your performance for each group and look at certain sort of evaluation metrics that tell you how well things perform with each subset. So things like F1 score, certain scores that are used in machine learning to evaluate models, particularly classifiers, that don't allow you to pretend like you've got a great model when you actually don't.
Yeah.
You want to make sure that you're predicting accurately across the distribution that you're predicting over. So
therefore, anything going into it can be predicted out fairly rather than only working for certain types of data.
Exactly.
What would you recommend as a resource, like library, to use when you've got questions about this sort of thing? I'm sure there's so many bits out there. How can you trust what's out there? What would you recommend using as a source?
I think there's so many resources now online to sort of learn about data science. Kaggle is a great website and resource to learn because you've got a sort of community of practitioners all trying to solve open source data science problems that are posted, and sometimes there's prize money and people compete. So that's a great way to learn. As usual, textbooks, YouTube, Wikipedia, blog posts, documentation for certain libraries as well. Often there'll be sort of theoretical explanations of things that have been implemented in a Python library, let's say, that you can read and learn about. It's a big subject, and the learning never ends, really.
Definitely.
Yeah.
Thank you so much, Rob, for joining me. And if you've got any questions for Rob or any of our team, then if you leave them in the comments, we'll try and answer them. If you like and subscribe to videos, and we'll be back with another one next month. Bye.
Bye.